All right, let's jump right in. Did you know that at the very heart of modern physics, there's this huge, unavoidable conflict? It's a massive divide that really challenges our entire understanding of reality. So today, we're going to explore a pretty radical idea about how to fix it. And it's not by building a bridge, but by digging for a whole new foundation. You see, pretty much everything we think we know about the universe is built on two magnificent pillars. On one side, you've got general relativity. That's the epic saga of the cosmos, the really big stuff. On the other side is quantum field theory, which is the bizarre and brilliant story of the subatomic world. And here's the thing, each one is incredibly successful, predicting its own world with just stunning accuracy. So general relativity, or GR, think of it as our rulebook for everything that's immense. It paints this beautiful picture of a smooth, curving spacetime, where gravity isn't really a force, but it's just the shape of the universe itself. It's elegant, it's predictable, and it governs everything from the Earth's orbit all the way to colliding black holes. And then we have quantum field theory, or QFT. This is the rulebook for the tiniest things you can possibly imagine, and this world is a wild place. It's a world of pure energy, where particles just pop in and out of existence, and everything is run not by certainty, but by probability. It's messy, it's strange, but man, is it powerful. Okay, so here's where the problem really hits. You have these two masterpieces, but they seem to describe fundamentally different universes. And, as our source material puts it pretty bluntly, they're only right in their own domain. The moment you try to use them together, say, to describe what's happening inside a black hole, the math just breaks. It all falls apart. They flat out contradict each other. So what do you do? I mean, for decades, this has been the holy grail of theoretical physics, solving this exact problem. How do you unite these two pillars into one single, cohesive theory of everything? Well, the mainstream approach has really gone down two main roads. The first path is to quantize general relativity. Basically, you take its smooth, beautiful geometry and you try to force it to be chunky and probabilistic, just like the quantum world. The second path is the complete opposite. You geometrize quantum field theory. You try to take all of its chaotic forces and describe them with the elegant language of geometry. It's really a battle to see which theory is going to end up absorbing the other. But what if both of these approaches are just fundamentally wrong? Our source material offers a really sharp critique here, describing this whole quest as being built on flawed reasoning and perhaps even delusions of grandeur. Wow. I mean, that's a direct challenge to the very heart of the entire unification project. The core of this critique is pretty profound. It suggests that the belief that nature is fundamentally random is, well, a delusion. The argument is that the probabilities in quantum field theory don't actually describe reality itself, but just our own limited human perspective of it. And this, the source claims, makes the whole quest rely on a lot of hand-waving instead of solid foundational principles. This all leads to a fascinating and pretty provocative question that our source poses directly. With everyone so focused on forcing one theory into the shape of the other, there's a third option that's almost never mentioned. The third option is not discussed. Isn't that weird? And yeah, that weirdly undiscussed option is really the key here. It's not about choosing a winner between GR and QFT. It's about realizing that they might both be incomplete, that they might both be pointing to something much, much deeper. So, this third option proposes that both general relativity and quantum field theory are incomplete. They aren't the bedrock of reality, they are just structures, pillars, built on top of a deeper foundation that we just haven't discovered yet. So the goal isn't to smash them together anymore. The goal is to start digging. And to be really clear, this isn't about throwing out a century of incredible physics. Not at all. We don't discard the pillars. We just start asking, what are they built upon? What's the fundamental machinery that makes both of these descriptions true in their own little worlds? This totally reframes the entire mission of fundamental physics. The new goal isn't unification, it's explanation. It's to find and describe the next, more fundamental layer of reality, the actual foundational system that gives rise to both the quantum world and the curved spacetime of the cosmos. This new approach comes with a powerful call to action, a new philosophy really. No more probabilities, no more hand-waving, no more arrogance. It's a demand to get back to searching for deterministic machinery, for solid mathematical and physical foundations, and for the humility to admit that maybe our current theories are just one perspective, not the final word. So that leaves us with a fundamental question, doesn't it? After decades of trying to force these two great theories together, maybe it's just time for a different approach.
Instead of building a bridge between the pillars, perhaps the real work lies in digging up the ground underneath them. What do you think?